Alright friends, welcome to the new video, and this video I'm going to explain here the convergence that you have between MST, multiple spanning tree, and all other spanning trees. So we will first try a convergence feature. I'm going to increase the font size a little bit. Right. Between MST and here. So I have two switches. I'm going to play MST here, and I will play the per VLAN spanning seed, so PVST plus, and we'll see how it works. And then we'll also see convergence of layer 3, how fast or how slow is the convergence when there's some kind of issue that happens in the network. I have this switch as switch 1 and this switch as switch 2. Two switches, and they are connected on port number 23 and 24 like in all the previous labs. So I don't need to log in into Nexus right now. So user, I'm the user. Alright, so we are going to see what kind of spanning tree are we running here. We are running rapid. I'm going to remove it and I'll say spanning tree mode per VLAN spanning seed. So this is how you move between spanning tree to spanning tree. I do have interface VLAN 1, show run interface VLAN 1. I have an interface being created, and if I want to ping it here, can I ping it? 1.1.1.1. I have only one VLAN right now. Right, we'll see what's going on here. Show interface VLAN 1. Is it some problem? No, it's all good. Right, there was a convergence going on, so that's what is the problem with per VLAN spanning tree. The convergence is very slow. You try making any change on any of the VLAN and the convergence will create problems, right? That is the whole purpose of this video, to show you convergence between multiple spanning trees, MST to RSTP, MST to per VLAN spanning tree. In the last video, I showed the convergence between rapid per VLAN spanning tree and per VLAN spanning tree. Right? In this one, we are trying to compare MST to both of them, per VLAN spanning tree as well as to the rapid. So here I have per VLAN spanning tree. On the other side, I'm going to use the second node here. Show spanning tree to see what kind of spanning tree I'm running MST. How did I reach there? I said spanning tree mode MST. That's what you have to do. How many VLANs do I have? I have right now show spanning tree VLAN 1. If you look at my theory video, you'll realize how MST works. This is just a lab stuff here. Now I have only one VLAN, and I can see that it is part of MST 0. So any number of VLAN that you create, right, in MST, they are all based on the instance. So you do not run spanning tree directly on the VLANs. You run it on the instance, and inside the instance you can have VLANs. That is what is the basic behavior of multiple spanning tree. I would recommend to watch my theory videos for MST to have more understanding about it. For the time being, we just want to see convergence, how fast the MST and PVST will converge here. So interface gigabit 1. I have two links here, right? And I'll say show spanning tree. Both my links are up. I just want to say show spanning tree. I see one of the link is blocked. Very interesting stuff that has happened is the cost has gone up by 20,000. The cost is 20,000, right? Well, we have to see why it is so. Let's do this. Let's try doing spanning tree mode MST to see what's going on here, right? And I'll go back to the switch 2 to see what is the cost now, what is the new cost here. Still the same, and I'll go back here to switch, show spanning tree, and let's see what is the cost here. I still have the cost shooted up to 20,000. We are the root here, and we'll give it a couple of second time to finalize whatever it's doing here. They are still in, some of the ports are in listening, some of the ports are still in forwarding, etc. right? And I'll go back to switch 2. Alright, if you look at the priorities, those are all fine. Only thing that has increased is MST, right? Now the port cost. I'll come back to that. Before that, we want to just see the convergence process. So spanning tree mode PVST, and we want to ping from this guy here to MST. Ping 1.1.1.2. The other side is running MST. Right, I am not able to ping, probably because of the convergence that's going on. I will again give it a try. Rather, I should have given the command for repeat. So I'm going to give repeat now. Repeat. And we'll see how much time it's taking. So it is pretty fast as per its own standards, right? Now I will go ahead and do the same thing, and I'm going to increase a little bit value here so that we can see the convergence time. And I want to see how much time does it really take to converge. There is a very interesting thing happening. If you look at the switch 2 side, it says I'm the root. Alright, let's go back on this side to see what's this fellow telling. Show spanning tree. Alright, now that proves, right, that the common spanning tree, right, is understood, or per VLAN spanning tree that we have here is actually understood by MST, and MST you see here, it understands this is old STP. Wherever you see the legacy STP, wherever you see the word STP, that means that actually I'm interacting with the old STP. I'm interested in interacting with per VLAN spanning tree, etc. So it does have a backward compatibility. Because of it, you are able to ping. Because of it, the VLAN communication is working. Still, in MST, I have not configured any of the VLANs that I have. VLAN 1. I have VLAN 1. I have not configured it as part of any instance. Any VLAN that doesn't belong to any instance belongs to which instance? Instance 0 in MST, right? So MST 0 is here, and I want to see the convergence. From this side, I want to ping 111. I can ping. There is no problem. And I'll go back here. I'll keep my command ready, and I'll keep this ready here. Interface gigabit 23, and I'll keep it. I'll give it shut, and I'm going to issue this command just to see how much time does it actually take. Taking a lot of time, isn't it? And I'll also keep on trying show spanning tree here. So what's going on? One port is gone, and it's actually showing came to forwarding. Came to forwarding. All right. This practical is very interesting practical, right? It took almost 50 seconds. It took almost 50 seconds for switch 2 to actually converge. Even when on the other side that was MST, right? Even on the other side that was an MST, so still it took so much of time. What could it be the reason? So the observation number 1 that you have here is, the first and the foremost thing is PVST still takes 50 seconds. It doesn't matter that the other side is MST or rapid. Even if you have a rapid per VLAN spanning tree, right? This side you still have PVST, so that's going to take 50 seconds, right? In spite or despite of that, on the other side, what do you have? So the convergence is going to be faster this side, but the convergence this side is going to be slow. Can we repeat the sides and then see the practical? Right? So instead of, what I do here is, I'll come back to this interface. I'll make it no shut. Sorry, and this time I'm going to sit here on this switch, be ready with my shut command on switch 1, right? With my shut command, and I will issue the ping from this particular switch here. So here it is, and I'm just repeating the scenario. Just trying to repeat my scenario, right? And this side I'll get my command issued. So ping 1.1.1.1 because I'm this side, and I'll say repeat 10,000, and let's see what happens here. I'm going to say shut. What happened? Still taking a lot of time, right? Even, I'll tell you very interesting stuff. The switch 2 has already converged, right? Although I'm pinging from the switch, I can't really see what's going on here. Either I have to open another connection and then I can see. But the switch 2 has actually converged, but switch 1 has not converged. If I go back to switch 1 has taken another 50-second time. So what is the conclusion? Well, conclusion is same. It doesn't matter you are actually testing it from here or you're testing it from here, because either of these links going down, PVST is going to take the same time. Alright, so convergence is going to be almost same, because one side you have PVST, so it does not matter you have what do you have on the other side. If you have MST here and rapid here, in that case it doesn't matter. It will not be any delay. Can we try that? Yes, we can. So I'll go here on this switch and I will say, we'll go back and we'll no shut this interface, and I'm going to do spanning tree mode. I'll say rapid. The other side is MST, I'll just say rapid here, right? Show spanning tree. What do we have? We have rapid here, right? What do we have on the other side? On switch 2, show spanning tree here. I have MST here. Now we need to see what is the convergence time. I will go back to the same port and I'll try making it shut while trying to issue the same command here. I'll issue the same command and I go to this port, I'll say shut. Alright, and you see what happened. In less than 2 drops, right? Less than 2 drops it came back. Why? Because you are running MST here this time. You are not running per VLAN spanning tree. What are you running here? You are running rapid, sorry. You are running rapid here. So this side you have rapid and this side you have MST. MST actually uses in the background, it's multiple instance spanning tree, or it uses multiple rapid spanning tree instances. Alright, so you got it, right? It's actually, even with MST, it's the rapid and rapid. Couple of things that we need to notice here. One thing is I did not put VLAN 1 or any other VLAN into any instance. No instance. So if you do not put any VLAN into any instance in MST, it becomes part of MST0. MST0 is backward compatible with any other MST that you have here. Sorry, any other per VLAN spanning tree or any other spanning tree that you have here. Now, the question comes here, what if I put it into a spanning tree here? Right? So, I really want to do a separate video, but just because we are here, division 1, and I don't want to give it a name, I'll just say instance 1, VLAN 1. What did we do? We just assigned it spanning tree. Just want to see MST0 really doesn't have anything. Now MST1, and my VLAN is actually into MST1. Right? My VLAN is into MST1. So I will do this. I can still ping it, right? So even if it is in MST1, it is still backward compatible with the spanning tree there. And on the switch 1, if I still go there, I am still running show rapid spanning tree. Sorry, show spanning tree. I'm running MST, sorry. So I will change it to spanning tree not on 2. I have to go back to 1. This one. Let's check what kind of spanning tree am I running here. I'm running rapid here. So that shows can I ping 1112? Yes, I can. So it doesn't really matter what spanning tree you run. They will be compatible to each other. They are always backward compatible to each other. But the issue is the convergence. If you still have the old spanning tree, you cannot avoid 50-second delay because that side is still going to converge at that speed. So make sure you have, rapid, or you have probably, even if you're using per VLAN spanning tree, you can have uplink fast, and then you can have on the other side, the other mechanisms to avoid these issues. So that is how the convergence works between multiple spanning trees. Thank you for watching, guys.